Merry Christmas in July. So what the heck's going on here? Well, I love 3D printing. I really enjoy using PrusaSlicer, and I really love bringing joy to children at Christmas, which is fantastic because I have an opportunity now to take all those and wrap it into one. So let's get down to it. For the fourth year in a row, IC 3D Printing is working on a campaign in a cooperation with the Marine Corps and Toys for Tots. They're recruiting those of us that have 3D printers as their elves to help them print toys to distribute to kids through the Toys for Tots program. This is really awesome. I did this last year and I had a lot of fun with it. Here's how it works. IC3D is providing the filament. They've identified a variety of different models that we in the community can pick to print, sign up through their volunteer form, and they send us filament and we send toys. Then the toys get distributed by the United States Marine Corps and Toys for Tots and get into the hands of children to enjoy on Christmas. So a common discussion that comes up between the elves is, what printer settings are you using? How fast are you printing? How many are you printing? Well, that's where this video is coming into play. One of the models that's being featured this year is this little cute Jeep Wrangler here in yellow. So I'm going to be using this model to demonstrate how I go through the process of picking my slicer settings and optimizing for fast printing, but also excellent quality. Because while the default settings in many slicers will produce excellent results, they aren't always the most optimized for speed and quality at the same time. Because while it's easy to get hung up on the fact of how many toys have I printed or how quickly can I print one, just like the Benchy Speedboat Challenge, the reality is if these toys aren't up to good quality, if they're inferior, they're going to get rejected. And they're not going to produce the results we want by bringing joy to a child on Christmas. So it's much better to produce 20 or even 50 of an item and have it be a good quality than it would be to print, say, hundreds of them and not have them be good and we have to throw them out. Okay, quick side note here from future me. Wanted to point out something before we start getting in here that you may find really helpful. When you're in PrusaSlicer and we get into some of these settings, there's many of these that may not make any sense to you or may use a different terminology than you're used to from another slicer. One thing that PrusaSlicer does that is really cool is if you'll notice, most of these items can be rolled over and have a little preview that pops up that tells you a little about them. But you also can click on them and it will take you to a corresponding article on the prusa3d.com website that will give you more in-depth information and even sometimes some diagrams and pictures explaining what that feature really does. This is super cool. This is fantastic documentation, and I wish more of the slicing software took advantage and did similar things like this. All right, back to our program. So I've already drug the model over here and take a look at it. First thing we notice, it comes in at sides. So we can select that model, use the lay flat tool or place on face tool here, and flop that around and get it face down where it's a good place to print. Now, because the Prusa MK3 that I'm going to use to print this particular model has its best cooling from the front and sides and not from the back, I'm going to go ahead and take this model and rotate it 90 degrees because the front of this Jeep is where the most of the detail is. So that's where my cooling is going to be the most important. If you're using Ender 3 or another Creality machine, it's more likely that your cooling is going to be on the right-hand side. So you would probably want that Jeep to face off to the right. Now, first thing we're going to do is take a look at the time on here. So we're using the default 0.2 millimeter layer height and 20% infill. That's kind of excessive, but let's take a look here and see how long it's going to estimate that takes to print. 1 hour and 34 minutes. Not horrible, but if we take a look at our preview here, there is an awful lot of material inside this little toy. So first thing I'm going to do right off the bat is I'll bet we could take that down to 5%. And we've already knocked off a half an hour now printing. When we're looking at infill, there's two things to take into consideration here. Our strength is generally in our perimeters, our sides, and in our top and bottom layers, not the infill. Generally, all infill really is for is to keep the top, any bridging from collapsing. So in this case, 5% is actually probably going to get the job done. Right here in the hood, this is going to be able to come out over there and be supported. And we get up to the top here. Any machine with decent cooling ought to be able to pull that off. That's not too bad right there. I'm guessing we can go ahead and use this draft mode and go down to 0.3 layer heights. It's going to use 20% there. So we're going to say transfer that, keep our 5%. And now with our 0.3 millimeter layer heights, 5% infill, we're at 52 minutes. Now I've already printed one of those and it looks really good, and I'll insert a picture of that here for you to take a look at. But I think there's still a lot more that we can do to get the size and time down on this little Jeep. So the next thing I'm going to do is I'm going to look at where we really need infill, because all this stuff in here, we don't need it. And then also, see this purple zigzag stuff? That takes a lot of time for the printer to go back and forth and print all those little movements. One of the super powerful tools in every slicing software that I highly recommend you should take a look at every single time you slice a model is the sliced preview. We can find out so many things about what our printer is going to do by just taking the time to run these sliders up and down. So first thing I'm going to do is go all the way down to the bottom, and I see this logo on the bottom. This model is a paid model. Somebody spent the time to design it and develop it. They certainly deserve to be recognized for that. I bought this model and I'm giving the toys away as a gift. I'm not selling them or anything like that. So first thing I'm going to do is apologize to the designer for what I'm about to do, but I'm going to go in here to PrusaSlicer, right click, add part and cylinder. Grab that cylinder, I'm going to slide it into the model. I'm going to grab the scale tool and we'll scale it down a little bit. Now when we scale it, it moves up into the model. So we can come over here to the right hand side and hit drop to bed, and that's going to drop it right back down. Now we could slide that over so that it covers up that logo, slice again, and boom, we've knocked a minute off of our print time. Now if we come on up here, we do have these bumpers here on the front and on the back that need a little bit of support underneath of them. I know for a fact because I printed several of these that have bumpers like this, and I didn't properly support these, and if we don't have these little layers building up underneath of here, we're going to get a gap right there. I really want to have as little infill as possible. So let's turn off infill altogether. Now we're at 51 minutes in normal mode and going to no infill. Now we're down to 43 minutes. We saved 8 minutes. But when we look over here, this will probably be fine on the front bumper. It's got 1 layer, 2 layers, 3 layers, 4 layers that it builds up before it has to do that. Enough of the back and forth on that out in the midair. I know for a fact my printer has good enough cooling that it can do that. Over on this other side, same thing on the back. We've got 1, 2, 3, 4 before we get to our top layer. I think that will be fine as well. We can print out in mid-air to a certain degree. Now, if we didn't have those, there's some little tricks that we could do, and we're going to get to that in a minute. We've got these little squiggles over here, and what that's doing is providing support for this area right here as that moves in. I don't think that's really that necessary. So a lot of times that comes into play when we have ensure vertical shelf thickness underneath our print settings. So we were at 43 minutes, turn off that, and now we're down to 35 minutes. Let's go ahead and run this all the way up. So let's look up here. Let's turn that back on. So we're getting rid of it down here, up here on the top of these fenders, a little bit on the insides. That's great. Little things like that we can do that will save us time. Now, one of the reasons that ensure vertical shelf thickness is because when we get into these areas right in here, we don't have a lot of material. Often what we can do is turn off the vertical shelf thickness, but turn on a perimeter. And even though we added a perimeter now, we're at 42 minutes. So 42 minutes, 3 perimeters without the shelf thickness or with it. Same speed, but we're not going to have this shaking around. I always will take it off because in this case, adding the extra perimeter is adding an extra perimeter to the whole model. So while it might use the same amount of time, it's actually we saved a minute, I guess it's 42. We're going to use a little bit more material, but that is going to make our model a lot stronger and stiffer through those areas. And that's good because this is a toy for a kid. It's going to get dropped, beat up, tossed around and stepped on. So we want to make these strong and durable for these children as well. So that's a great place right there. Now we're 10 minutes off of our last print. So let's keep on coming up here. Good. No problems here. One of the things we can look at is PrusaSlicer will give us some, if we see any yellow like underneath it here, that's our inside perimeters. Our orange is our outside perimeters. We can see that up here in our key. So we're going to watch these things, and right here, there's a little issue. So we got this little fill right here. Then we got a layer on top, and then nothing. So I think we're probably going to have a little issue right here, and that's getting into our hood, which then starts building out over great big open space. So that wasn't a problem when we had infill in the whole thing. What I could do is add a modifier, go in here to add a modifier, a box. It's going to drop a box in here, and we're going to apply settings to this box. So I scale this box out a little bit so it covers the width of the truck. And I can then go over to the gear on the generic box, infill. I can change that to 10%. And we'll just go with grid since that's the default. And now look at that. We got infill in just the nose of this truck. So now that's going to probably print perfectly, no problem. But all this infill down here, it's not doing anything. That's just wasted time and material. See, we've added back on now 7 minutes. So what we can do is take this box and scale it down. And I'm going to make this box just apply on the hood. And when I look here at my box, that box is 6 millimeters tall. So now let's slice. We're back down to 44 minutes. So we only added 2 minutes here. And now we can see that we've got just a structure here of starting at 54, 15.8, and coming up to 65, 19.4. So that is plenty of time for that to get going. And if we look at this first layer here, we can use our slider down here and watch our toolpath. And we'll see that it's going to go around the perimeter. It's going to build this little area out on the side, which will probably be all right. And then it's going to take a curve. That'll probably sag a little bit. Then it's going to come from this side over to here. Now that, it could easily bridge that. Then it's going to come back over this way. Again, easy bridge, no problem. And then it's going to do a little curve like this. So these ends will probably sag out. But then the rest of that in those corners is probably going to be fine. Next to on top of that is going to build on top of that. And what's going to happen is that we build those layers up multiple times. By the time we get up to here, it's going to be good, solid infill. Now, we used grid. Let's take a look and see what happens if we do like rectilinear. Grid, rectilinear, and gyroid are the three that I find usually work the best for this. Rectilinear, yeah, got a big hunk over here hanging out. Let's take a look at gyroid. Gyroid's going to be even worse in this case. Now, if we'd have been, our first gyroid had gone across the side like that, I'd have been really happy. But it's not. So what we're going to do is we're going to go back and stick with grid. Let's check line too. Line is another really good one. And see here. No problem. No problem. Actually, all three of those movements would be perfectly fine and should reach an anchor. Then our next one would build on top of that. And it probably would be good too. I'm going to go with line. Let's do line. So we're going to do 10% line. And we really probably don't need even that much of it. So let's grab our box. Let's make it a little smaller here. We need to make sure that we've got all of our areas covered up here, or else it can do weird things sometimes. Now, let's see, we had that kind of weird spot there, so maybe we'll come back down a little bit. And see what that does. All right, 44 minutes. We've got 1, 2, 3, 4, 5. I think that'll actually be okay right there. because this layer right here, this line is going to lay across something. So I'm good with that. So now we've only added a little bit of material right there. Then these layers are all going to build on top of that. Cool, no problem. We get up to here, we start making a box shape again. Boxes are easy. And there, we're going to come up to the top now. And now we've got this big bridge up here. Now, depending on your printer, you might actually be able to pull that off. But we've only got 4 layers. So what we probably should do here is add a little bit of infill as well. Now, we could do this trick with the box, but we're going to do the whole area. So there's another trick with PrusaSlicer that we can do. We're going to right click on our model and we're going to go to height range modifier. Now, first thing, let's take a look at our model. Our model is 33, we're going to call it 34 millimeters tall. So when we do our height range modifier, we're going to come over here. It's going to start at 0. Orange is the bottom. We said 34, right? So if we type in 34 is our top layer, we can see it goes all the way up across the top of the Jeep. And let's say 4 millimeters. So we're going to make this 30. So we're just going to target that 4 millimeters right there, which I'm actually thinking, looking at it, probably more than plenty. Let's see what 2 looks like. So 3. We'll slice this here in just a second. See. Now, we've got layers and we're targeting this range here. Now we can have multiple ranges and target different things in here. We're going to do that in a second as well. So now we're going to click the gear right here again, right click. We're going to go infill. We're going to go for 10%. And I know line will be great for this one. We take off time? Oh, I see. We're targeting, oh, my number changed. 1. Yeah, and we were targeting too small of an area. So we're going to do the 3 millimeters there, which should be roughly 10 layers. There we go. Look at that. We got 1, 2, 3, 4, 5, 6. 5. We have 5 layers of infill that are going from side to side, crisscross all the way across there. Every single one of those, if you've got good cooling and your machine's dialed in well, is going to reach the other side. So when we come in here to start doing this infill over top of it, this should lay down beautifully and we should have a beautiful roof on top of this Jeep. 5 is probably good. We could probably push it to 3 if we wanted to, but I'm okay with 5. Got this curve right here. And when we look at the sliced view, we can see we got some of these kind of steep layers here. We're going to come back over to the 3D view and we're going to go up here to the variable layer height tool. We're going to be a little bit more subtle in this curve. And one thing we can do is use this variable layer tool and come in here and we can see right now it's telling us that we're at our base layer height of 0.3. And if we click with the left mouse button, we're going to start pulling this curve over to the left and we can see the numbers are changing and getting smaller. We're going to create a little arc here down to about there, the base of theirs, because we don't need it to be at 0.2 the whole way. We want our curve kind of gradually rolls over so we can have our lower layer heights kind of gradually roll over as well. And now we can see we've got that added benefit of having a little bit nicer arc here at the top. And it looks good all the way along there because we're gradually changing the layer height. It's not going to be nearly as noticeable. You're not going to see a marked line here when the layer height changes. The other thing we could also do with that is take an area where these windows are that have very little detail and go the opposite direction. So we can come back to our layers here, come over here and hit the plus sign next to these other ones and add another layer range. And now we can take a look. Our second one down here, notice it's up above, but we want to come down. So we're going to go down to, let's see, we can go over to our slice preview and just drag down and find out exactly where we want to start. We want to start at 21.5 and go up to about 26. So let's say, or 29. So let's say 22 to 29. So we're going to say 22 to 29. And there's now our new area that we're going to target. All right, we can go higher. There we go. This will be a marked change. So the closer we can get to one of those feature lines, the better. But we don't want to overlap our other range. All right, that's cool. Let's go with that. So here we can just simply say, instead of 0.3, we're going to go 0.33. Slice 45. So now we're at 45 minutes. We've shaved off 8 minutes of our original time of 58 minutes for our one with 5% infill. Not a ton, but remember that we also added these extra perimeters, so this toy is also now a lot stronger. Now the next thing you can do is start looking at speed. This is an MK3 that I'm very familiar with, and I'm pretty comfortable with what it can do on its speed settings. So now we can come on over and we can start taking a look at our print settings. So we got our 0.3 layer height, 0.2 on our first layer. This printer can easily do a 0.25 first layer height. We've got perimeters of 3, our solid layers 4 and 3 on the bottom. Because they're 0.3, that means this is going to be about 1 millimeter on the bottom. We'll go ahead and make that a 4. This is a kid's toy. We've turned off the vertical shell thickness. Our infill is 0. Our skirt and brim, Prusa defaults to having 3 layer heights on its little skirt that it uses to purge. We can turn that down to 1. Now speed. Let's go back here and take a look at this preview. If we look up here, we can see where our different features are broken out and their timings. So 16 minutes, 36% is in perimeters. External perimeters is 12 minutes. Infill, 49 seconds. We added 49 seconds to the print by adding those 2 infill areas. Solid infill is basically our bottom, 11 minutes. Top solid infill, 2 minutes, essentially the roof. Bridge infill, which is that part on the very top and a little bit of the hood, is 1 minute. Gap fill is 46 seconds, and the skirt's 11 seconds. The other part we need to look at here also is speed, because we said our perimeters were 65 and 35 on our externals. Now we've got this small perimeters, which is 30. I know on my external perimeters I can also go up to 50. So now when I'm looking at my speeds here, I can see what it's getting classified as what. One thing I'm looking for is like those small perimeters. Well, those small perimeters we said were 30. 30 is going to be down in this blue, green, teal area. Got a little bit right there that's green, a little bit down here that's blue. So we don't really have to worry about that affecting our speed. So our biggest parts of our speed are going to be in those 2 perimeters. So I don't really need to go out pushing this small perimeter limit. If I had a lot of small perimeters, little circles or something, and I thought I could push them, I might bump that up. For the heck of it, I'm going to go ahead and take that to 40. Infill. I know our infills, this is our bridging our lines, because it's just get a little bit there. I know I can take that to 100. Actually, I can take that to 120. My solid infill, which is basically my floor, I know I can take that to at least 100. My top solid infill is essentially my roof. We can take that roof to at least 50. We don't have any support material. We do have some bridges. Depending on your machine, your cooling, will depend on what you can do there. I know I can usually take those a little bit more, especially because they're small. Gap fill. Now gap fill, we said, see where we're at now, 41 minutes. Our gap fill, if we look under our feature drop down, is 46 seconds. There are some times in a print when you go into this preview and you look and you're going to see white everywhere. We've only got a few little spots of white. And depending on where that white is, it may not make any difference in the world. But if it's doing a ton of it, and a lot of times it'll be like between some layers here because your layer widths are just a little off, removing that gap fill sometimes can really save you some time. And in PrusaSlicer, the way you get rid of gap fill is you set that to 0. Now travel, my non-printing travel moves, 180. Yeah, I could go a little bit higher, but I'm not going to worry about that. First layer speed, I'm going to be printing PLA on PEI. I know I can push that a little bit. Now, the thing we've got to take a look at on our first layer is these parts here where the wheel's attached. The rest of this, it could fly through that. These are kind of delicate, so we don't want to get too crazy here. For now, we're just going to live with that. It's a small part, 39 minutes. So now let's look at this acceleration control. Acceleration is when the printer is changing speeds. It's changing directions and it has to take off from a standing stop to going up to its top speed, like this 65 millimeters a second. It doesn't happen instantly. This is the ramp in which it speeds up to that point. If you're having problems with ghosting or something like that, a good place to start turning these things down and see what happens. Small prints, well-tuned printer. I know I can usually turn this up to 1500 at least with no problems. I probably can go even higher than that. My infill especially, I know I can go way higher. Can't see it. Bridging, we can go a little higher on it. Bridging easily. First layer. Now here we can do those first layer, taking off from those dead stops when we're doing that infill. So that'll help us a little bit there. While we're at it, since our lowest one here is 1200, let's go ahead and change that to 1200. Now, 38 minutes. Will we take off a minute? If we're putting 12 of these on a bed at a time, we just took off 12 minutes. So just because we're taking off a minute doesn't necessarily mean, it's like, it's just a minute. We're not going to be printing these one at a time eventually. Multiple extruders, we're not doing advanced. Here is our extrusion widths. I'm using a 0.4 millimeter nozzle. Generally speaking, you can go at least 150% of your nozzle width without any real big problems. So my default extrusion width, I'm going to take to 0.6. First layer, not much down there. Let's take a look at it real quick. Okay, so these, oh, look, dropped a minute. So these details right here are where we got to be worried. We're going to take a look at that first layer. Generally, I like to have a beefy first layer unless it's super detailed. That's good. I can live with that. That's okay. We lost that little bit in the center, but this is the first layer. There's the second layer on top of it. No problem. So we're going to leave that first layer at 0.5. Our perimeters, these are these yellow lines, not outside details. We can take those to a 0.6. External perimeters, the orange lines, it's already at a 0.6. Infill. Now here's one thing you can do if you want to beef up your part and you want to make it extra strong and you really want your infill to count. Bump up that infill. We're going to over extrude and go nuts at 0.65. Solid infill, we want to cover as much space as possible in the shortest amount of time. We're going to go to 0.6. Top solid infill is our roof. Let's see here. Oh, look, down to 36 minutes. So our top solid infill is going to be this red, and this red. Because this is a big area, let's make sure that looks fairly good. So let's leave our top solid infill at 0.45. There's not a lot of it, so going to a larger size is not going to gain us a lot. Flow rate, that's the bridging flow rate. I actually find turning this down a little bit can actually help because your bridges aren't as extruded. There's not as much material, so it's less likely to sag if it doesn't weigh as much, especially if you hit it with some good cooling. Sometimes even going down to 75% on these bridges. Hey, let's do that. Let's go down to 75% because it's smaller materials, thinner, and so when the air hits it, it cools quicker. Cooling PLA rapidly can draw huge lines in the middle of air. Slicing stuff here for the resolution and all, that's not going to be an issue. Elephant foot compensation. Now this is one, especially for a model like this, we've got to take into consideration. 0.2, half the layer height, or layer width is a real common place to be. Let's change this to 0 and see what that actual first layer looks like. So there's without the elephant foot compensation on, and 0.2. We didn't really lose much. We lost that little center there. Elephant foot is when the bottom of your print flares out onto the bed. I'm going to change this to a 0.1. I'm going to be printing eventually a lot of these at once, so I'm going to make sure that this label objects is checked. It didn't used to be, but it has been in the more recent versions of PrusaSlicer. What that does is I also print through Octoprint all the time. When I'm printing a dozen of these at once, and if one of them fails, I don't have to kill my whole print. Because those objects are labeled, I can tell Octoprint to kill just that one object and skip it the next time. So look, we're down to 36 minutes for this print. I'm happy with 36 minutes. That's a pretty respectable place to be. So now before we print this, there's one last thing we need to do. When you go back to our preview mode here, we're going to go all the way down to the bottom, layer by layer, and just double check and make sure there isn't something weird happening in here that we overlooked. This is a super critical thing that you should do every time you're slicing something new. Okay, now see here. Look, I'm going to show you something right now. Something happened here. We changed the setting somewhere, and we've got over on the left-hand side for the grill we've got 1, 2, 3, 4 layers before this top fill is in place. But on the back bumper, we lost that little piece that was back there. Not sure what setting I changed. I could go back and go through all my settings to try to find it, or I can just fix the problem. Because I know for a fact that if I leave it like this, we're probably going to wind up with a gap right there. I've already printed a few of these toys and had that happen. So what I'm going to do is I'm going to go back to my model here. We're going to right click. We're going to add a box modifier. We're going to bring it to the back here. We're going to scale it. We're going to move it over.
Scale it back and down. Drop it down. So that's just about like, let's see if we go here. We want to get about 5 layers below that bumper. So that we're at 1.3, so we want to go down about 0.4. Now, there's some of it hanging up on top. Doesn't matter. There's nothing up there, nothing to infill. So now I'm going to right click. I'm going to do infill. I'm going to do 5% rectilinear. And that's 1, 2, 3, 4. Okay, because we came up, there's nothing on the outside, but we came up on the inside now is drawing a little bit of infill on the inside there because our box came up above there. So what we can do now is our box is 2.48 millimeters tall. Let's go to 1.3 and we're at 0.3 millimeter layer height. So that's going to be roughly 4 layers. Look at this from the side here. We're going to drag this down. It's just the top of that bumper. And now, no infill on the inside of there. We've got 1, 2, 3, 4 layers, which that will easily be able to accomplish to give us a good solid layer there. And now notice that comes out. So this perimeter goes in the middle of that. This is going to be fantastic, super strong, no problems whatsoever. 36 minutes. Bumpers are good. Coming up, no problem, no problem. Got our little corners there. They're still crossing over. Got our lines. This one's good. That one's in the air, but those two should overlap. Our bridging is all, because our bridging is building out. So the more this goes up, the stronger it's going to get out here. And we're starting at the front and moving our way back. So that's all going to be good. Then box mode. These are fantastic. And then boom. Now, I'm going to print one of these and I'll come back. And we're back 36 minutes later of printing. Remember what the first one looked like? Well, let's take a look. So here's our second one at 36 minutes. This is our first one. That was 53 minutes. Interestingly enough, our first one is 13 grams. Our second one here is 14 grams because we put more plastic in that outer perimeter. So let's go ahead and play like we're at the eye doctor. A, B, A, B. Let's go ahead and take a little closer look at them side by side, head on. Remember the changes that we made. In the roof line up here, our second one, which is on the left, has more steps on the curve up here than the first one does. We can see that. There's coarser steps over here and there are finer steps over here. Beyond that, to me, the two of these look identical. Now let's take a look at the sides. We have our first one on the right and our second one on the left, but notice we're looking at different sides. If we take a look at our other picture, the two of them here and here, there are a few little issues with this that we can see. When we're looking at the front of these, if we look in the grill, this leftmost grill in both of these is a little rough compared to the others. And then if we look at this right fender on both of them, it's a little rough as well. And if we look at the side profile, the driver's side or left-hand side, we can see some roughness in the pillar here and right in here. It's much cleaner over here. Now, why is that happening? We go back to our model and take a look at it again. We can go back over here to the view feature, and underneath the show, we can click on retractions. And what do you know? On the front of it, it's that left grill, left side of the grill, we've got some retractions. Again, in the right side, or this left fender here, we've got some retractions as well. On this left-hand side, we've got some retractions in here. So let's see if we can clean those up. Another really cool feature in PrusaSlicer is we can now paint on the seams. So this bottom icon down here is where we can paint on our seams. We'll change our brush size down. It's a little smaller. Instead of having a seam in the front, a seam on the corner, and a seam right here, why don't we take all of our seams and shove them towards the back. So I'm going to follow this little line right here, this contour of this back window. And we're just going to come along like this. Could also, if I wanted to get fancy, I could try to hide the seam in this crease right here, or in the back window here, or something like that. But let's go with this for right now. Let's see what this gets us. So we'll slice that, and we'll see that by forcing the print head to come back and do its seam on the back versus kind of where randomly wherever it is in the model, it has added an extra minute to our print time. But I'm going to gamble on the fact that this is actually going to give us a better looking print, and in this regard, it's worth the extra minute. So let's find out. And here's our results after 37 more minutes of printing. We can see on the right-hand side that our grill is much cleaner. We don't have these little pock marks over here. The fender here, we don't have the little divots here. Up here in the windshield, there's a couple little divots. We don't have those either. And our roof looks very much the same. Now, there is one issue here. We have this little blemish right here. And what that is there was a little chunk of filament that got stuck when it was doing its bridging to build that infill for the hood that got caught up and stuck up there and just kind of burned and made a little mess. That could easily be taken care of and tuned out probably by reducing our flow rate so that it pulled it across there a lot quicker. And we didn't have an opportunity for it to kind of build up in there. But that's something that could easily be tuned out. And in my opinion, when we look even at the lines over here on this hood, this one looks even better as well because we've moved those retractions. And we can see looking at the side here, all these little artifacts in the side are gone. When we look at the back now, we can see where they went. They're in this back left-hand corner here. But they're all localized in one spot. And in my opinion, it's way better to have these right here than it is a little here and a little here. And this right here, this is what's the iconic look of a Jeep. So this is what I was able to achieve with just a little messing around in PrusaSlicer for my MK3. Can you replicate these for your printer? I don't know. But the trick is you try, you start in a place, you keep tweaking, and you just keep going along, iterating and see what the results are. Now I'm going to print hundreds of these, but I'm making my mistakes and doing my testing one at a time, 20, 30 minutes at a time. And I'm expecting to do 6, 7, 8 hour prints on multiple printers, loading these up as much as I can to print these for Toys for Tots. And if you'll remember, our very first slice right out of the box using the stock profile with 20% infill was saying this was going to take an hour and 34 minutes. We've shaved almost an hour off of each one of these things. Think how many more I'm going to be able to print. Now, I've teased a 20-minute version of this. How did I get there? Well, a bit of trolling, I'll be honest. These Jeeps were printed with a 0.6mm nozzle. They don't look so great, do they? Starting on the right-hand side, we've got 28 minutes, 27 minutes, 25 minutes, and in the far left is the 20-minute Jeep. Not acceptable. In fact, in my opinion, none of these are acceptable. But they show a progression of how far I was able to push the limit, find where the limit was, and know that I couldn't go there. But I did accomplish what I think is an acceptable 0.6mm 27-minute Jeep. This Jeep was printed in 27 minutes on my Anycubic Predator Delta with a 0.6mm nozzle. It's not perfect. We are losing some details, but we've got most of our details on the sides. We've got a few little marks here and a few little marks here, but these are easily able to be tuned out. I did the same trick that I did before by moving the seam to the back. This looks really good in person. Yeah, we are losing some detail on the front here, but this is where material comes into play. We did our tuning for speed, but now there also has to be tuning for material, and different materials are going to behave differently at different speeds and different temperatures. So this orange Jeep was printed with the exact same G code as the one on the right. They're both printed in Printed Solids Jesse PLA. The right is Jesse PLA red. The left one is Brad's orange. Notice how much more detail we have in the grill over here. Now, we got a little gap over here that we don't have so much over on the red one, but everything else up in here looks really good. This is a material thing. I really think by just simply slowing down a little bit and taking this 27-minute Jeep down to, say, maybe a 29-minute Jeep, or tweaking my acceleration or just a small little changes, I really believe I'm going to get this Jeep looking good. And again, we've got really good detail around these windows, a little bit of a blob down in here, and you can see there's a little gap right here, but I know these can be tuned out. So I hope this video has been helpful for you, giving you an idea of some things you can do in PrusaSlicer, or any slicer in that regards, that can really speed up our print time, but still maintain quality and maybe even fix some issues that you're having. Please leave me a comment and let me know what you thought. I'd also really like to hear from you if you'd like me to dig in deeper as how I went through my 0.6mm process, or if I should dig into the slicer settings and how I would optimize one of the other toys that are being used in the Toys for Tots campaign this year with IC3D. So thanks for sticking around to the end of this video, but I really would like to ask all of you to consider participating in IC3D's and the Marine Corps' Toys for Tots campaign this year, and consider getting involved in donating your time and material using your printer to bring some joy to a child this Christmas. Thank you.